Hi everyone, this is Mr. Chang. Let's do Unit 7 in Math 10, and this unit is about relations and functions. This unit seems very long. Look at the table of content, like there are 12 lessons here. But this unit is easier than the other, and then also this unit, the main purpose is to get you ready for the next two units, which we will do in term 4. Okay, so we're doing flipped classroom, we're doing lesson 1 today. So let's turn to page 389. So this is lesson 1 on unit 7. This lesson reviews some important concepts that will appear throughout the next 3 units. Okay, so like once again, this unit just gets you ready for what's coming up. It first starts with Cartesian system, the coordinate system that's created by this guy. Okay, so you can read some history about this. It's quite interesting for some of you interested in the history. And then the main thing is just know the order pair x and y, all right? X-axis, y-axis. And when you go to university, you could have the z-axis as well, so you can have 3D graphing. But in high school, just do 2D, x and y, okay? And then it's ordered pair, so which means the order is important. You do x first and then y, okay? It's the order pair. You do x first and then y. And any point can be located in one of the 4 quadrants. So we use Roman numerals. So the first one, this is quadrant 1, and then you go in counterclockwise direction. Quadrant 2, quadrant 3, quadrant 4. And then the origin is right in the middle. Okay, to state the coordinates of any point, you need to state the x first and then y. So point A is 2 units to the right from the origin, so 2 and 4. So you will write 2 and 4. You separate by comma, put it in brackets. For B, it go to the left 3 units. Okay, so it's -3, 0. And then C is 6 and then -3. And then D is 0, -3, 0, -3. Finally, O represent the origin, 0, 0. Write the coordinates of points in the second quadrant, so which is here, you write point E. In the third quadrant is write point F. Well, how about B, for example? Well, this is on the axis, so you don't say that it's in the second or third quadrant. They are on the axis. And finally, complete the following table. Okay, so every quadrant for the x coordinate will be positive, positive for quadrant 1. Quadrant 2 will be here, which is negative x coordinate but positive y coordinate. Quadrant 3, both of them are negative. Finally, quadrant 4, you have positive x-axis and negative y coordinates. Okay, so this is just all review. So this lesson is very straightforward. All right, moving on to the next page. We have some example describing pattern using a linear relation. So this chapter introduced relation and function, and this laid the foundation for upcoming chapter. And also, you spend a lot of time in grade 11 and grade 12 learning different kinds of functions and relations. So why do we study math? Because we want to study relation, how things are related together. And x and y coordinate will help you relate two things at a time. So let's look at one example. And then you can see how powerful it is once you find out the pattern. You can use what you find out to predict what's going on. All right, now first, the example here is using toothpicks to make triangle. So to make one triangle, you need 3. To make 2 triangle, you just add 2 more, you make another triangle. And then you add 2 more, you make 3 triangle. So to complete this table, you will write 5, 7, right? Well, how about fourth one? Well, looking at the pattern, you realize just adding 2 more toothpicks, you make 1 more triangle. Adding another 2, you make a triangle. Okay. Now, graph this data in the table below. All right. So, 1, 3, 2, 5, 7, right? So you just graph it. So in here. So number of toothpicks, 1. The number of triangle, you need 3 toothpicks. 2 triangle, you need 5. You need 7. You need 9 and 11 and so on. All right. Explain why you do not join the points. because number of toothpicks, number of triangle have to be whole number. So it doesn't make sense to have like half of a triangle. Number of triangle has to be whole number. By connecting, which means something in between exists, right? 1.5 a triangle, 2.7 a triangle, that doesn't make sense. So you don't connect the dots. Describe the relationship, all right? So the key for upcoming chapter is to find out how to relate these two quantity, T and P. What's the relationship, all right? So you look at the data, they go up by 2 every time. So every change of triangle, you adding 2 at a time. So for that one, you will stick a 2 to T, right? Adding a triangle will increase by 2. So adding one triangle increase by 2, 2 triangle, and so on. All right? And you need to figure out what number. So if I have one triangle, I need 3 toothpicks. So you add a 1 there. Okay. So examine the data, you find out this is the relationship. The number of toothpick you need to increase, you multiply by T, and then you add like some base unit, like what do you need to start with. Okay, so this will be the formula, all right, for the equation. And that's the power of math. Once you have the formula, you can answer the next question very quickly. The next question is, how many toothpick you need for 27 triangle? Well, you don't really need to make one to find out yourself, right? Once you see this pattern, you can just punch in a number. Then you find out the answer, right? The answer is you need 55 toothpicks to make 27 triangle. Well, how do I know, right? Because by math, I know it. I didn't count it one by one. That would take forever, and that's a very dumb way to do it. You use math, you use logic, you use reason, you use equation to find out the answer very quickly. And then vice versa, you can also say if I have 83 toothpicks, well, how many triangle I can make, all right? So you sub in 83 into P, and then you solve it. You minus 1 divided by 2. You can make 41 triangle. So every equation describes a relationship between two quantity. In this case, is T, the number of toothpicks, and number of triangle, and P, the number of toothpicks. So for all the other application, it's always between two quantity. And then you write an equation to relate them. Okay. Let's look at next example. Next example, we have current and voltage. And for some of you probably learned this year when you work with electricity. And then we have something called the Ohm's law. We'll look at that later. This is how you relate current and voltage. So basically you have a circuit, and then you examine the relationship between the voltage and current at various points. Now, when you plot something, you need to work out the scale. For this one, the number are quite big, so you need to put every 3 units, or something like that. All right, 3, 6, 9, 12, 15, and then you put 30, and then you put 45. Right, you need to work out the scale, and then here maybe every half, right? Every box is half because of the data. So look at the data, you find out this is what you need. Okay, so this is the current, I. This is the voltage, and then you plot it. Okay, here, and then this other point. So you can look at the data. So 4, they have 48. Okay, they have here, they have here. Okay, so if you connect all the dots, you have the following. It's a linear relationship. Does it make sense to join the points together? The answer is yes. Because current takes on any intermediate values. So we'll talk about continuous data and discrete data in the next page. Use the graph to determine the voltage. So this is called interpolation, right? For 2.5 ohms, 2.5 ohms is here. 2.5 amps is 30 volt. All right, what's the relationship? You can see this one go up like that. It's a straight line, start from 0. And then a half give you 6, 1 give you 12, so and so on. So the relationship is 12 times more. So here is my relationship. So I'll write that. So V is 12I. Equation. Use the equation to determine the voltage when the current is 6.2 amps. V is 12 times 6.2. And then you put it in your calculator. And then you got the answer. Finally, resistance. So we learned this is called the Ohm's law. We'll learn that in science. Okay. So basically, if you compare the formula, you find out the resistance is 12. The 12 represent the resistance of the circuit is 12. And then the unit is interesting. It's called ohms. The symbol for ohm is like this. Okay, 12 ohms. Once again, you will learn that in science. All right. So we come to the end. Last page. So when we graph two functions, we can have continuous variable, which means the variable takes on every values in between, like every value within a particular interval. So decimal point is possible, like 1.25 and so on. However, for P and T, they only take on limited values. They are not continuous. Then you call them discrete variables. For example, they take on only whole numbers or like every half number. Okay, so are the following discrete or continuous? So when you measure time is continuous. Like you can be as accurate as you want. Like finish it in 10.14 second, right? Or like finish in 12 second. So you can be very, it takes on all the values in between. Okay, number of student. This one have to be discrete. You cannot have half a student passing Math 10. Height of a student is continuous. People height can take on any intermediate values. Now, shoe size. Okay, this one is interesting. When you go buy a shoes, when you look at shoe size, they take on discrete values. They take on discrete values. Something wrong with the pen. They pick on discrete values. However, the actual measurement of the length of our feet, well, of course we know it's continuous, right? People can take in any, like the measurement of their feet, they have continuous measurement. However, if you talk about shoe size, you can only get 12 and a 12 and a half and 13 is discrete shoe size. All right, that's the end of this chapter, and I hope you enjoy Flipped Classroom, and then we'll have Unit 7 entire on Flipped Classroom. Bye.